I'm Scott McConnell, this is Joshua France, and we have Matt Harris behind the camera, and we're the 10 check group. So the way that our 10 check bracelet system works is that we have a bracelet that has three outputs. We have one positive status LED indicator, which shows that the wristband is not tampered with. We have the red indicator, which will show that it is tampered with. And we have a vibrating motor, which will wake up the tenter if they are about to fail a 10 check. The other part of the system is the hub. So the hub includes 4 different inputs. One is the large button, which starts a 10 check. We have these 2 smaller buttons, which increment and decrement what's called the reset integer, and the reset button right here. And then the form of output for the line monitors would be this right here, which shows the status of all the groups since the last check, and also the value of the reset integer. The way that the reset integer works is that it will indicate which node will be reset once the reset button is clicked. So just to show how it works, right now we have our wristband here, and we have our other 2 mock wristbands here and here, and they are all at status green, which means that they're not tampered with. So if we run a 10 check, you'll be able to see on the screen what happens. If I hold the 10 check button, first they will all be pending, and then over time, they will not, because they're not synced up.
Well, that's a good thing to explain.
Yes. So, so right now they just both failed. Group number 1 and group number 2. So that shows that because the status indicators are green, that shows that they're actually not synced up in terms of timing. Luckily, our reset button can both sync up the time and reset the tamper flag. So first, we will send a reset signal to group number 1. And then we will send and then we will increment the reset integer. We see that number 2 is also failed, so we'll send a reset signal to them as well. And now when we send an overall check, we will see that they all end up passing. So that was an indication of the first way that a tenter can fail. Another way that they can fail is if they remove the wristband and set the tamper flag to high. So if I undo this wire, you'll see that the bad status LED turns on, and even if I plug it back in, it will continue to be on red.
So basically, like, that's supposed to mimic someone tampering with the wristband in order to take it off and foreseeably like mess with the system. Because if they can take it off and they don't have to physically be there, this is our way of knowing that the wristband is on and it has stayed on. And if it comes off, this red LED comes up, and they shouldn't fail there. They shouldn't pass their 10 check.
Yes, so now this is group number 1. So if we send a new 10 check out, we will see that the two others passed, but this will it's a 10-second process of making the 10 check, so it's still pending. But after 10 seconds, it should end up failing. So this is just a way for line monitors to know whether someone has tampered with their wristband. And the other part that you weren't able to see because we were looking at the screen is that if someone has tampered with their bracelet but they don't know it, and say they're asleep or something like that, we should let them know that they're about to fail. So if we send a signal,
this rumble motor is supposed to essentially like wake the person up if they're about to fail the 10 check, or if they're failing the 10 check. It's normally housed within the wristband, like right in that little hole, if you can see. But it works when we're going off of the power from the computer, but when we go into battery power, it doesn't seem to work as smoothly.
We were able to fix our problems with the vibrating motor by including an N MOSFET in our circuit, attaching the drain to the VUSB port on the embed, attaching the signal, which is caused by a digital out, to the gate, and attaching the vibrating motor to the source, which is then grounded. So now if we run a 10 check when the wristband's tamper flag is high, we will see that the motor starts vibrating. This goes on for 10 seconds and then stops.
Just to talk a little bit maybe about the way we're authenticating when a user should pass. We touched on a little bit, and we've seen now the 2 cases when it can pass. The first being if the system time of the wristband trying to receive is wrong. The second being if the tamper flag of the wristband has been tripped. For both of those, the solution would be for the user to notice their status LED is red and going to the 10 check hub to get it reset. The reset signal does 2 things. It would reset the tamper flag of a wristband if it was set to high, the only way those tamper flags can be reset is from a signal from the hub. And the second thing that reset signal does is it syncs up the wristband's system time to the system time of the hub. In this way, we use the system time of the wristband and the status of the LED or the status of the tamper flag of the wristband to actually have a wristband pass one of these checks.
Should we reset my band tick?
Sure. So right now, we just showed what happens when you pull a tamper flag out on the wristband like you wanted to take it off. So we can see the status LED is red, and we see that, again, group 1 passed that check. So they know that they need to get it reset. We change our reset integer back to 1. We send out a reset signal. Then now we can see on the wristband the status LED has changed from red to green. It's good to go. And so if we trigger a new tent check, it passes. And there we go. So that's a good demo of our system and its current point. Thanks.